This is A2Pure maths, and we are looking at integrating powers of trig functions, which tend to be a little bit tricky. Here's our problem. If we go back to differentiation and say we let y equal sine to the 5x, the way we would differentiate this is to use a chain rule. So I would let u equal sine x, and we actually rewrite this in as sine x n all to the power of 5. Then du by the x gives us cos x. Of course, if you differentiate sine, you get cos. And we have y equals u to the 5. And then dy by du is 5u to the 4. So dy by the x is dy by the u times the u by the x. So it's 5u to the 4 cos x. And that gives us then 5 sine to the 4x cos x. And you get used to this wee pattern here. If I differentiate this, I get this. That drops a power, the 5 goes to the front, and then sine differentiated as cos. So you can kind of use that to your advantage then to do some of the other ones. So say you had something like y equals cos to the power of 8x. Remember, we're still in differentiation here. That's going to give us then 8. Cos to the 7x. Do you see what I've done there? I've kind of dropped the power. And then whenever you differentiate cos, you get minus sine. So it's going to be sine x. And when we pick the minus out the front. So how does that affect us? The deal is then if you differentiate this and get this, then if you integrate this, you're going to get this. So weirdly, integrating something like sine to the 4x cos x is an awful lot easier than integrating sine to the 4x, because there's no kind of obvious way to kind of get back then, so it's just going to give then an answer of something like this. If I want to integrate this, this looks really like this, so my answer then would just be a fifth sine to the 5x plus c. So that can help us whenever we do come to integrate things like this, and it's actually different for odd powers than it is for even powers. And we'll just kind of run through a few examples here and see if we can get our head around it. So first of all, I'm going to start with, let's go for the integral of sine cubed x dx. The deal is, as I said in the previous video, you just can't integrate them like this. You need to rearrange it and get it into a form that we know. So you want to split this up strangely into a sine x and a sine squared x dx, and we know that sine squared x plus cos squared x equals 1. So we know sine squared x is 1 minus cos squared x. So I can rewrite this then as the integral of sine x upon 1 minus cos squared x dx. Multiplying this out, I get sine x minus cos squared x sine x dx. So I know this looks an awful lot more complicated than this, but this is much more integrable. I don't know if I've just made that word up or not. I know how to integrate this, and weirdly, even though it looks more complicated, I know how to integrate this. It's like one of these backwards ones in that I've just done. So let's integrate this and see if we can get an answer for us. If I integrate sine x, I get minus cos x. Sorry, just give me a minute. I'll take this wee bit out separately. This reminds me of like a cos cubed type thing from what we did up here. So if I look at this, and you don't need to do this if you're all over this, but if you have y equals cos cubed x, if you end up differentiating that, what are you going to get? You're going to get 3 cos squared x times by this differentiated, which is minus sine x. This is very like what we're trying to integrate. However, we have a 3 there, so we need to kind of then divide 3, so it's going to be plus a third cos cubed x plus c. So that's your general technique if it's an odd power. let's try one more here and see if we can get it to work. So let's go for cos to the 7x dx. We want to separate that out into cos x upon cos to the 6x. And we know that cos to the 6x, so we know cos squared x is 1 minus sine squared x. We just kind of did that on the other page there. So this is 1 minus sine squared x all to the power 3. So you end up then with that. If you sit and multiply that out, you can take my word for it, you're just going to cube the thing out, so it's a kind of a bracket. You do FOIL and then multiply it by itself again. You'll get then cos x. Or you could maybe use the binomial to expand it out if you want. It's 1 minus 3 sine squared x plus 3 sine to the 4x minus sine to the 6x dx. And I'm very aware that this looks 10 times more complicated than this, but weirdly we're getting this into a shape where we can now integrate it. Multiplying out our bracket, we now have cos x minus 3 sine squared x cos x plus 3 sine to 4x cos x minus sine to the 6x cos x dx. How do you integrate this then? Integrating this, it gives you sine x. Integrating this is going to be a power of sine cubed. Do you see that? That's actually the 3 already there. So it's just going to be minus sine cubed x. Next one's a wee bit tougher. This is going to be like a sine to the power of 5x. Differentiate, then you get cos, remember 3 here. So it's going to be a plus 3/5 sine to the 5x. And here then this is a bit like a sine to the 7x. If you differentiate sine to 7x, you get something that looks a little bit like this. So it's going to be minus a 7th sine to the 7x plus c. So that is how you go about then integrating odd powers of sine or cos. As you can see, it is quite complicated. You just can't do it, so you need to rearrange it into a form that we know something that you can integrate. For even powers, we just need to go back and use our double angle formula kind of over and over again. So let's pick an example. For example, then sine to the 4x. We know that, what did we have? So sine squared x was equal to, it was this one here. Do you remember kind of from the last video whenever we were integrating sine squared x? So I'm going to rewrite it slightly different today. So it's a half upon 1 minus cos 2x. So that was using then our double angle formula. That means sine to 4x is going to be this all squared. So that's going to give us half upon 1 minus cos 2x all squared. It's just a bit easier for the fractions. So that half is going to get squared first of all. So I'm actually going to take the quarter out the front. And then it's 1 minus cos 2x all squared. So it's 1 minus 2 cos 2x plus cos squared 2x. What are we trying to do here? Powers of trig you just can't integrate, so we want to try and change them. Weirdly, powers of trig you can't integrate. However, double angle, treble angle stuff you can integrate. There is like a backward differentiation that we can use. So we're good with that. We can now integrate this. We can now integrate this. We're still then struggling with this. So we now need to use our double angle formula again. And we know that cos squared A is a half upon cos 2a plus 1. So I'm now going to change this as if change the 2x here for an a, so it ends up then kind of giving us a 4. So I can rewrite this now as 1 minus 2 cos 2x, and then it's effectively this squared plus a half cos 4x dx. So I have used the kind of double angle formula here twice. I've used it for sine to change it into this, and then down here we still have a squared. You can't integrate those, so we need to change it up and sort it out from that. We can now integrate this. Would you believe? Integrate 1, we get an x. Be careful with this one. So if I'm integrating cos, I get sine. If I'm integrating cos 2x, I would get a half sine 2x, but the 2's already there, so that cancels out my half. So it's going to give me minus sine 2x. You could, of course, have joined the half together here with the 1 to give me kind of 1.5 and integrate, but I just kept it separate for the minute. So it's plus a half x, and then same format here as before. So I'm going to do, if I integrate cos, I get sine. If I integrate cos 4x, I get a quarter sine 4x. So times in by the half, then it's going to give me an 1/8. Sorry, I've made a mistake here. I shouldn't have an integral sign. I've now just integrated this. Plus c, and then multiplying everything out. Let's go for x plus a half x, so that's 1.5 x, or 3 over 2 times by the quarter. Give me then 3 over 8x minus a quarter sine 2x, and then an 1/8 times a quarter plus 1 over 32 sine 4x plus c. So let's do a wee quick review in terms of what we've done. This is higher powers of trig functions, and we're integrating them. If you have an odd power, you separate it out into the even power and then multiply them by itself, and you use different forms of 1 minus cos squared or 1 minus sine squared loads of times to separate it out. What that does, it gives you some two terms that you can integrate. So that was our sine cubed x. This was our cos 7x. Again, we separated out into cos 6x and cos x. Change that to 1 minus sine squared 3 times. Multiply it all out. Once we multiply our 3 by our cos x, weirdly, even though this is 10 times more complicated looking than this, these terms we can integrate, and we end up with that. For even powers, we need to just keep using in the double angle formula and kind of changing it out. So sine to 4x, we know that sine squared x is a half upon 1 minus cos 2x, so it's this squared. Multiply this all out. I took the quarter out the front, if you remember, and then if a squared appears again, so we now need to deal with that. If it's up to 6, you need to just kind of keep getting rid of any of the kind of squared terms and then go on from there.